Hey guys, welcome back to Akacademy once again. So in this particular lecture, we are going to talk one very important reaction, that is Baeyer Villiger reaction. This is a kind of oxidation reaction, right? And this is very important. And in this particular video, we will be also solving one previous year question from the CSIR-NET. So now let's understand first of all what happens in this case. In this case, we have any one ketone or the aldehyde, right? And that get converted into the ester. Here we will have RCOO and this R, right? And the reagents which we use, that may be peracid, right? And the second thing, that may be peroxide, and the third thing, that may be actually caro acid, which is H2SO5, right? This can also be used. So basically we have three reagents. The first one is peracid. We use peracid, and we also use peroxide, and especially H2O2, if I talk more precisely, so that is H2O2, and the third one which we use is caro acid, right? So here the conversion of a ketone or the aldehyde into the ester takes place. As you can see, the difference in between these two is only of this oxygen. So here we have one extra oxygen which is present in this, right? So now let's talk about its mechanism, actually how the mechanism proceeds. So first of all, here let's see one example of peracid. So what is peracid? If we have this double bond O, we know in carboxylic acid we have RCOOH, right? So here we will have something like this one extra acid which you can see over here, this one extra acid will be present in this case. So now let's see what happens and how the mechanism proceeds. So first of all, we have this R, C double bond O, and here we also have this R, right? If I write the acid, so here we will have this OH, and here we will have C double bond OR, like this, right? So this is the acid, as you can see, which is present over here, right? And we also have these two electron in this case. So now in the next step, what will happen? Actually, this acid which you can see, this OH is going to attack on this carbonyl carbon, and this double bond will shift over here, right? So what will happen? Here we will have R, C, here we will have this as O minus, and one more R which we have over here, and here we will have this O and this H, and positive charge will come on this oxygen, right? And here we will have this O, C double bond O, and this R, right? If I write it like R1, R2, R3, so that would be much better. So let's write it as R1, R2, and this as R3. After this, what can happen? We have this double bond O, right? So this oxygen will abstract this proton, and in the next step we will have R1, C, here we will have this O minus, and here we will have this R2, and here this O and this O, and C double bond OH. Now the positive charge will come on this oxygen, and here we will have this R3. Now actually what happens in the next step, this double bond which you can see, because the oxygen have positive charge over here, so this will try to maintain its valency, so that is going to actually pull this electron density towards itself. So this will migrate over here, right? After this, once this will migrate, so what will happen? The double bonds which you can see over, the bonds between oxygen and oxygen which you can see over here, actually this bond will shift over here, this bond will migrate over here, and this R2 which is present over here, this will migrate over here, and this negative charge which you can see will migrate on this carbon, right? So now let's write the product and what will be the product in the next step. So here we will have this R1 C double bond O, and this R2 have migrated on this oxygen. So we will have R1 C double bond O over here, and here we will have this O and this R2. So this is the product which I was talking here, right? So this is the ester, plus Along with it, we will have here R3, and this double bond will O will be over here, R3 C double bond O and this OH, right. So, one acid and one ester will be formed. So, this is the two products which are formed in this case. Now, the question is actually which R1 and R2 will migrate, right. So, actually this is totally dependent on the migratory aptitude. So, here I am telling you the migratory aptitude, and please remember this. So, first of all we have this hydride, and after this we have this phenyl, after this we have tertiary carbon ion, secondary carbon ion, 1 degree carbon ion, and then we have this methyl, right. So, this is the migratory aptitude which you should know actually, right. Now, in the next step we are going to see some examples of this Baeyer Villiger oxidation reaction. So, now let us take one example, and with using that example we are going to find out the trick actually how this reaction we can write within just 1 minute, not even 1 minute, just 10 seconds only, right. So, first of all let us take one example. If we have this CH3 C double bond O, and here we have this C2H5. So, in this case what you can observe, in this case here let us take CH3 COO, right, OH, right. Now, what will be the product over here, which you can what you can observe over here. Here we at one side we have this CH3, and on the another side we have this C2H5, right. One side methyl and another side methyl. The migratory aptitude of this methyl is less than this ethyl. So, this oxygen which will be inserted, that will be between this carbon and the carbon that which is, and the group which have higher migratory aptitude. So, obviously this one. So, oxygen will be inserted on between over here. So, this O, and here we will have this C2H5 like this. Now, let us take one more example. If I say we have this pH, and here we have this C double bond O over here, right, and what we have over here we have this CH3, and we have used the per acid CH3 COO and this OH, right. So, where the oxygen will come? So, in between this methyl and this CH3, this phenyl has higher migratory aptitude. So, the oxygen will come over here, and here we will have product like this. Because what we can observe over here, suppose let us take this as R1 and this as R2, right. So, this as R1 and this as R2, let us take this as R1 and this as R2. So, what you can observe over here, if we have this R1 and R2 over here, so in this step the steps will be same, and here we will have this R1 and R2. So, what I had told you, the group which have higher migratory aptitude, so that is going to migrate. So, in this case if R1 is this phenyl, so R1 will migrate over here. So, once this R1 will migrate, because in this case the R2 was migrated, right. If the R1 will migrate over here, so the oxygen will be in between this carbon and this R1, right, like this. So, that is why you can understand actually what I am trying to say over here. Now, let us take one cyclic example, and the reagents, the next reagents that is very important which we can use is MCPBA, right. So, this is the most common reagents which you will see in most of the time in the exam, right. So, that is also used for this process. This is what metachloroperbenzoic acid, right. So, that is also per acid. So, if I use over here, let us take one cyclic example. If we have this 5-membered ring and this ketonic compound, right. If I am using MCPBA, so in this case what will be the process? In this case we will have double bond O over here and one oxygen over here, and this will become a 6-membered ring, right. So, because this is 5-membered ring, so either this one or this one, any of this can migrate. But if I place a methyl group on this, so what will be the product, right. In this case let us take, if I have methyl over here, right. So, in this case what will be the product? So, because this carbon have higher migratory aptitude, so that is why oxygen will come at this position only, right. This methyl will come over here. So, the methyl which was over here. I hope you understood all about this Baeyer Villiger oxidation reaction, right. So, this is the basic of this reaction. However, there is one very famous example, right. In that case what happens, what I have told you, in that example actually opposite of this reaction takes place. So, in that case the less migratory aptitude, the actually group of atom which have less migratory aptitude that migrates. But in this particular video we are not going to discuss about that problem, and we will make a separate video for that, right, because that is only one example. In that case what happens, uh, actually the oxygen which we are inserting in between the carbonyl carbon and the carbon group of atom, the carbon which have higher migratory aptitude, but in that case actually the opposite of this takes place. So, for that I will make a separate video, and in that I will discuss each and everything, why that happens and how that happens. I will discuss everything regarding that. So, this is all about the Baeyer Villiger oxidation reaction, and now it's time to solve one problem which was asked in CSIR-NET, right. So, this question is from the CSIR-NET, and we are going to solve this question, and this was asked in actually December 2011, right. So, this question is from December 2011. So, now let us solve this one and we will understand actually what happens in this case. So, first of all what you can see, we have one ketonic compound over here, right, ketone over here, and pH MgBr is given, Grignard reagent. So, that is very easy step, right, and here what we will have, here we will have OMgBr, and here what we will have, this phenyl will get connected over here. After this, in the next step, this is the first step which we completed over here. In the next reagent what we have used is TSOH, right. So, what it will do, this TSOH actually this BROMG which you can see over here, actually this will become OTS, right, and if it will become OTS, so in that step what will be the process, here we will have this pH and here we will have this OTS, I can write it like this OTS, and here this hydrogen which is present over here, because this is a very good leaving group. So, in this case what will be the process, dehydration may takes place. So, this hydrogen will shift over here and this OTS will be removed, right, and we will have something like this, and here we will have this pH and double bond O will be over here, right. So, basically this is OTS is getting removed. Now, we have find out our A product. So, this is A, right. Now, in the option what you can check, in the option we have either this may be correct or this may be correct, this may be correct, but this cannot be the answer, B cannot be the answer actually, right. So, among A, C and D, one will be the correct answer. Now, let us try to find out which will be the correct answer. Now, in the next step we have used this BH3 and SME2. This is what? This is a kind of hydroboration reaction. So, in the hydroboration reaction I will make a separate video about this, right, once we will start with the reagents. So, in that case we are going to understand all the reagents now. So, this is what hydroboration reaction, and in the hydroboration reaction actually the OH get introduced on that carbon on in the, this is what OH get connected with that carbon in the alkene which is actually less substituted or less hindered, we can say, right. So, OH will come at this position. So, we will have something like this, OH will come at this position and we will have pH over here, right. After this, the next thing which we have PCC. PCC is what? PCC is actually oxidizing agent, right. This oxidizing agent, this is what? Pyridinium chlorochromate, pyridinium chlorochromate, right. So, this actually oxidize the alcohol to the ketone or the aldehyde on the basis of their actually either they are primary alcohol, secondary alcohol, on the basis of that this oxidize. So, this is what? This is secondary alcohol. So, this will get oxidized into a ketone. So, here we will have this double bond O and here we will have this pH. Now, you have got the actually substrate which we use for the Baeyer Villiger oxidation reaction, and here we have this MCPBA, right. Now, what will be the product? You can easily predict now, right. And in this case, what I had told you, you don't need to write much mechanism and all. And here what I had told you here, because this carbon will have higher migratory aptitude as compared to this one, so oxygen will get inserted between these carbon only, right? So oxygen will get inserted over here. So what will be the final product? So the final product which we will have here, double bond O, and here we will have this oxygen, and here we will have something like this. This is 3 3 1 2 3 4 5 6 and 7 membered, right? So this will be the product, and here we will have this pH over here. So this is your B product and this is your A product. Now it's time to match the answer. As you can see in the A option, right, A is also matching and B is also matching, but here in the C this is not, this won't be correct answer, right? But here in the B, this oxygen is introduced between this carbon, carbonyl carbon, and this one, so this is also not the correct answer, right? So the correct answer will be on this option A. I hope you understood how actually we can write the mechanism for this one as well, right? So for this, actually if you have understood in the video what I have told you, so definitely you can write the mechanism, and with the short trick we have solved this, right? In the organic, if you are will do very good practice, so definitely you can actually solve the problems within just 1 minute, 2 minutes, like that only. So this is all about the Baeyer Villiger oxidation, right? And we understood all the concepts regarding this. And in the next video, we will start with any other name reaction, and along with any problem which was asked in your previous year exam. And thank you so much for watching this video.